Hi, welcome to the class. Today we'll start our discussion on nuclei, and the topic which we'll start is radioactive decay law. So, this radioactive decay law, and it is also known as Rutherford and Shorty theory. So according to this law, what it says is that the rate of disintegration of a radioactive nuclei is directly proportional to the number of like the sample to the remaining sample. Okay, so if initially we have more number of nuclei to disintegrate, the rate would be faster, and if we have less number of nuclei, the rate would be slower. So the rate of disintegration dn by dt, where n is the number of the sample which we have, okay, the nuclei sample which we have. So this rate of the disintegration, it will be directly proportional to n. Now what is n? N is the number of remaining sample, right? If we have 100 gram, we started with 100 gram, so 100 gram would disintegrate faster. But if it remains like now 100 gram, out of 100 gram 50 has been disintegrated and remaining sample is 50 gram. So 50 would disintegrate slowly as compared to the 100, because it is the rate of disintegration is directly proportional to the amount of remaining sample which we have, right? Now if you remove this proportionality sign, we would get a constant which is lambda, and lambda is the disintegration constant, and we will put a minus sign because we know that the sample would decrease. So what is lambda? Lambda is the disintegration constant. Disintegration constant. So this is a very simple relation. If I plot a curve of this, you know that if time would decrease, this number of sample would, if time would increase, the number of sample which is there would decrease, right? So this is the graph between number of sample and time period. So as the time is increasing, this sample is decreasing. So this is one of the important relations, right? Now one more relation I can derive from this relation, and this derivation is not in the syllabus, but I would like to do it for your reference. What I will do, I will send it here. So dn is equals to minus, and I will bring n there, n minus lambda dt. I will integrate both sides, dn by n minus lambda dt integration. Dn integration of dn by n is log base e, n is equals to minus lambda would come out, integration of dt is t, and then plus c. C is the integration constant. Now how do I find the value of c? So I would find the value of c, this c, by using the initial condition. So what is the initial condition? I am saying that if time is equals to 0, it means the disintegration process has not started. If the t is equals to 0, then the sample number would be initial number, which would be n naught. So I would use this condition here in order to find the value of c. So if I put t is equals to 0 here, as and when I will put t is equals to 0 here, I have to put this n is equals to n naught, and in that case the condition would be log base e n naught is equals to, I have done this is equals to 0, and this will give me the value of c. So I will put the value of c here again, and if I do that, log base e n is equals to minus lambda t plus log base e n naught. I have put the value of c. Bring this here. So log base E n minus log base E n naught is equals to minus lambda 2. You know that this is log A minus log B, and log A minus log B is log A upon B is equals to minus lambda 2. Now if I remove the log from this side, the other side I had to put the e to the power, that is exponential. So I am removing this log here, n upon n naught is equals to e to the power minus lambda 2. So this brings me to this important relation, n is equals to n naught e to the power minus lambda 2. So this is an important relation. This relation we should remind, and I think you do not have this derivation of this expression in your syllabus. So that is one expression which we have derived. Now the next thing which we have to understand is something known as half-life. Now what is half-life? Half-life. So as the name is telling you, half-life, it is basically the time period at which the remaining sample becomes half of the initial sample. Okay. So initially if I started with, let us say t is equals to 0, I started with n naught. N naught was the sample, right? So when t will become t half, which is the half-life, n will become n naught by 2. Simple. Means whatever sample with we started, now the half of that sample is remaining at this particular time, and that is why we call it half-life, right? Now if I put this value here, this value if I put here, so I have to make the time, because this value, this condition will follow only when we have half-life, right? So n naught by 2, here I have put it, and then is equals to n naught e to the power minus lambda, and then instead of t I will put t half. Correct? Now n naught gets cancelled out, 1 by 2 e to the power minus lambda t half. If I reciprocal this negative sign will go away, e to the power lambda t half. Now again I am using that condition that if I remove this e, you remember I have removed this log and e has come. So if I remove this e, log will come back again. So it will be log base e2, and then e will go, so lambda t half will remain. And we have the value for this log base e2 is 0.693. So the value of this is 0.693. The value of log base E2 is 0.693 is equals to lambda t half. And here we have got a relation between this lambda, which is the disintegration constant, and this number, which is 0.693 upon lambda. So this is a relation which we have derived between the half-life and lambda, which is disintegration constant. So this is there. Now another thing which we have to understand is the average life. So average life is like the total time period, the average of all the time period, total time period to disintegrate this substance fully. So the average time taken by this radioactive substance to disintegrate fully is the average life. Now I will just write the direct relation, because there we have a direct relation, and the direct relation is T average is equals to 1.44 T half. This is the relation which you all have to understand, right? Now one more relation I have to tell you. That relation is simple. If, let us say, n is equals to n naught by 2 is there. So what I can write, I can bring this n naught here is equals to 1 by 2 to the power 1 I am writing. When this condition we will achieve this condition when we have the half-life. So first half-life happened we got this. First half-life, when first half-life happened, n is equals to n by 2. Now second half-life happened. Again, one more half-life happened. So if one more half-life happened, then what would be the relation now? N is equals to n naught by 4. Why 4? Because one more time the sample would become half. Initial sample was n naught, half of that initial sample is n naught by 2. Now n naught by 2 is remaining, half of this n naught by 2 will be n naught by 4. So I can bring, what I can write, n by n naught is equals to 1 by 2 square. Can I write 1 by 2 square? So now see, how many half-lives has happened? 1. How many half-lives has happened? 2. If 3 half-life happened, what will be the relation? N by n naught is equals to half to the power 3. So basically here I am getting the number of half-lives, and if I summarize this whole expression, I might write it like this: n by n naught is equals to half to the power n. Now what is this n? N is nothing but the number of half-lives. Number of half-lives. So this relation is also an important relation. Also, if you time taken for one half-life, n is equals to 1, time taken for this one half-life is t half. Right? And the total time taken for the disintegration is t. Total time taken for the complete disintegration is t. So don't you think that n, which is the number of half-life, into t half, time taken for one half-life, this will give me the total time for disintegration. Number of half-life multiplied by time taken for one half-life is equals to what? The total time period for the disintegration. So this relation also we will use. So you must remember all these relations, which was n is equals to n naught e to the power minus lambda t. Then second, t half is equals to 0.693 lambda. T average is equals to 1.44 t half. This relation, n by n naught is equals to half to the power n, where n is the number of half-lives. N into t half, n is the number of half-life multiplied by time taken for one half-life is equals to total time period. So that is there, right? So in the next class we shall discuss few numericals based on these relations, and that would be it for today. Thank you.